Hi guys, and welcome to this, the most important video you're probably going to watch today on seasonal indices. Yes, it's part of the Further Maths Unit 3 and 4 course here in Australia and around the world, and hopefully you've been following along with all the previous videos. It is building on, and it is our penultimate video for this series. It is really good to have you here. If you haven't already done so, can you do me the greatest of honor and clicking that little doohickey in the corner to subscribe for YouTube. There's about 19 people watching these videos at this moment. If we could make it to 20 would be awesome. Get it out there, and if you can tell your friends would be greatly appreciated as well. And head over to mathsguru.com if you're not already there, where you can search all of these. It's nicely ordered by textbook, and there are downloadable notes as well. Right, that's enough of the promotional stuff. Let's get on with the fun stuff. So by the end of this lesson, hopefully you're going to know what a seasonal index is, and in realism, it's actually not that challenging. Understand how to calculate seasonal indices from raw data, how to de-seasonalize data, turn it back into raw data, and how to understand and interpret seasonal indices. Okay, now in previous lessons, as I say here, we've looked at 3 mean smoothing, 5 mean smoothing, 2 mean, 4 mean, median smoothing. All of this has the word smoothing in it. Okay, so the point of smoothing is to be able to come up with some sort of a trend and to see whether there's an increasing trend or a decreasing trend to describe our data, because Further Maths, if you remember, is about describing the data. Yay! In the previous lesson, we came up with this graph here that time was along the bottom and room percentage, this was hotel occupancy rates, and we saw that by drawing on this trend line, this line of best fit, this least squares line, if you want to call it that, would give us an idea of whether things were sort of increasing, decreasing, or in fact had no trend whatsoever. Now, in this situation, seasonal data, those seasons throw things and make predicting that little bit more challenging. So what if we could take out the seasonal data? If we could actually remove those wobbles that are there because of ice cream sales in the summer being much, much more than ice cream sales in the winter. What if we could sort of fudge the data so we could raise up the ice cream sales in winter and sort of reduce them a little bit in the summer to sort of come up with some statistical way of seeing whether we could smooth that out a little bit. And realistically speaking, seasonal indices is just another way of smoothing. And if we remember that the whole point of this is to come up with some sort of trend line, life should be good. Okay, seasonal indices. Now, seasonal indices tell us how a particular season, generally a day, a month, or quarter, compares to an average season. The most important word there is average season, because to work out this data, these seasonal indices, you need to use averages. Okay, but we're looking at comparing one season with the average for all seasons. Okay, so here's an example of ice cream sales. I love the idea of ice cream sales. I love ice cream. Who doesn't? We look at the sale of ice cream sales. So I basically made this data up, and I've got January, February, March, April, May, June, July, August, September, October, November, December on the top. And now I have my sales. And as you would expect, we can see that my sales in January and December are a lot higher than they are in June or July. Why? Because here in Australia, it is winter in June and July, and as such, not many people buy ice creams, or obviously a lot more people buy ice creams than you think should. We want to now take our data and rubbing up this stuff, and I would like to be able to compare, well, on average, how much more was my January sale? Or on average, how much less was my July sale or my June sale? Well, the way we do that is, as I keep saying, we take averages. So the first thing I want to do with any of my data that I'm given is I want to work out the average of all of the data. Now, to keep the video shorter than it would otherwise be, I'm actually going to do a lot of the calculator work using screenshots. So as you can see here, what I've done is I've added all of the data together to give me 12,250. So just adding all of those values gave me 12,250. Now I added the data with a 1,435 and working that way to my last data item as 1,630. You can't see that on my calculator because it sort of goes off. Then, having worked out the total of all of those, I divide it by how many data items there were, i.e. 12, and out comes the value of 1020.83. 1.33. So there's my average. So that's approximately equal to 1,021 ice creams. Now, do you notice the next part of my calculator? I actually do the same thing again, but this time I reverse the numbers. The best thing to do with seasonal indices to make sure you don't make any silly mistakes is to now add the data again. And what I did was I added it backwards. So you'll notice in this situation, my first number was 1630, and I added all the numbers in reverse order. Now the good news was that I ended up with 12,250, which when I divided by 12 gave me 1021. So I am fairly confident with those 10 seconds of extra effort I put into this that my average is the same. So hence, fingers crossed, all of my seasonal indices will be the same. Seasonal indices? What are you talking about, seasonal indices? So we are now going to use that 1020 value to compare all of my other sales figures to that figure there. But first thing I want to do is go back to the idea of percentage multipliers. Now remember, percentages can be more than 100. If I have 120%, that just means I've got 20% more than I started with, all right? Or a 20% increase on where I started. If I have 80%, then if we use 100% as my reference, then to get from 100 to 80, I've had a 20% decrease. Now, if you can get that sorted now and that understanding crystallized, then life is absolutely amazing for you, because the rest of it, I promise you, is just interpreting numbers. Now, actually, as it turns out, we can also write percentages as multipliers. So 120% can actually be written as 1.2 as a multiplier, all right? So if I want to make things bigger by 20%, I can multiply it by 1.2. Likewise, if I want to make something 20% smaller, I can multiply it by 0.8. How do we do that? Well, ultimately, you know, to go from a decimal to a percentage, I simply multiply by 100. Yes? And likewise, to go from a percentage to a decimal, I divide by 100. So looking at this, I've come up with a quick example. If I open a bank account with $50, at the end of the year I have $60. How much more do I have than I started? Well, my percentage increase, or my percentage, my percentage increase or decrease is given by, well, I had $60 at the end, $50 at the start. So if I do 60 divided by 50, I end up with this 1.2. So I've got 120% more than I started. Now you're going to say, how did I know that? Because I can take this 1.2, multiply it by 100, and that stands for 120%. So 120% of what I started with basically means the same as a 20% increase. Oh, awesome. Now, if we can understand that, we can now move on to our idea of seasonal indices. These are nothing more than percentage multipliers. Right, we know the average of all of my data was 1021. So now I want a way to compare 1435 to 1021 in terms of a percentage multiplier. How do I do that? Well, funnily enough, we have a formula. Our seasonal index, which is our percentage multiplier, just think about it that way, is equal to my actual figure divided by the average of the season. Hold on a moment, we have all of that information. We know the average of the season is going to be 1021. So I'm now going to take each of these values here, and I'm going to divide them by 1021. So firing up my calculator, leaving that formula on there, what do I notice? Well, my first value for January was 1435, which I've divided by 1021 to give me that massive value there. What about this one? 1360 was my value for February, which I've divided by 1021. So all of these have been divided by the same values. Moving this up so that it's a bit clearer, what do I now see? Well, I notice, ladies and gentlemen, that I've turned, let's just actually bring it back down again, 1.405. Now, the good thing about seasonal indices is you have to round them to the sort of accuracy the question asks you. At this moment in time, the more you round it, the more dodgy your answer is going to become. Dodgy? Did I actually just say that? I did, but what I'm trying to say to you is try and keep it to 3 decimal places if possible. later on life will be a lot easier if you can. Okay, so we had 1.405 for January, and I've written that down as 1.405. 1.332, 1.332, 1.034, 1.034. And ladies and gentlemen, here are my final seasonal indices. Again, just think of these as multipliers. So if I now look at this value here, 1.405, 1.405, if I multiply that by 100, I get 140.5%. So that means there has been an increase of 40.5%. So on average, we sell 40.5% more ice creams in January than we do in our average month. That's what a seasonal index means. What about this one here? 0.785. So 0.785, multiply that by 100, it gives me 78.5%. Now again, remember we are referencing this to 100. So how do I go from 100%, which is my average, to 78.5%? Well, hopefully I'm just going to take away 21.5%. So it would mean that in May, we sell on average 21.5% less ice creams than our average. Try that again. In May, we sell 21.5% less ice creams than we would in an average month. That made much more sense. Now, a word of advice, because the questions here in exams are actually always pretty much the same sort of ideas. If you add all of these values together, you should end up with the sum of how many data items you have. So these should be approximately adding to 12, all right? They should approximately add to 12. If I had only 5 data items and I add the seasonal indices together, they'll add to 5. If I have 10 data items, add all the seasonal indices together, they add to 10. Now in a later video, and I'm adding a video to this course, I'm just going to do a load of VCAA questions relating to this. This video is going to be long enough without adding VCAA questions onto the end. So I'll release 2 videos at the same time, the theory and the questions. Okay, so what does this screen here mean? Well, basically, this screen is very much just saying if you add all those values together and divide by how many there are, it should equal 1. Why? Because all of the averages should add to 1. The problem is we get here 0.99975. Why? Well, because we rounded all of these figures here, and because we rounded them all, we had a bit of an issue. So just realize that when we add all those together, they should add to the number of data items and life will be good. Now, when it says understanding seasonal indices here, I've already explained that before, but I'll just do it one more time. So in January, we had our seasonal index was 1.4. Now, realistically speaking, it's 1.405, which when we multiply that by 100, gave me 140.5%. Referencing how do we go from 100 to 140.5, I add 40.5%, and if we think of this now as add, as being replaced by the word increase of 40.5%, then you will be a gun at these in examinations. November, our seasonal index, what did it say in November? It was 1.556. Again, if we were to do that, 1.556, multiply that by 100 gives me 155.6%, and so that would be an increase of 55.6%. Those ones that are bigger than 100 are really easy to do. The ones that trick people are the ones that are less than 100, and as I say here, we need to be careful here because May, as I already worked out before, let's choose a different month. Let's choose June. So in June, we had 0.412, times that by 100 gives me 41.2%. How do I go from 100 to 41.2%? I am going to take away 58.8%. And so, because we are taking away 58.8% to get there, it means that is going to be a decrease, because a minus means a decrease. Turning the data from seasonalized to deseasonalized and back again. All right, so seasonalized data is normally my raw data. So the most important thing to here is to say that seasonalized data, let's highlight that, and I'm going to write under here, is actually my raw data. When we deseasonalize it, we actually are trying to reduce, as I said at the start of this video, we are trying to sort of smooth the data out. So those months where we're sort of significantly under the average, we sort of bump them up a bit, mathematically. Those that are sort of much higher than the average, we sort of reduce them down a bit. We sort of smooth out the edges to give it some sort of pattern that we can see an increase or a decrease. Why this works, luckily, you don't have to know. All you do have to know is the formula that I print here. That to deseasonalize a figure, to fudge it, to smooth it, we take the actual figure and we divide it by its seasonal index. And so we have an example here that says the seasonal index for cold drink sales is equal to 1.33. The last summer, a beach kiosk's actual data. So if it says the word actual data, then that word actual, where has it gone? Just highlight it, is just another way of saying raw data. So our actual figure was given as $15,653. What were the deseasonalized sales? Well, the example is there, the formula is there, and our data is there. And as you can see, all I've done is say, well, okay, then our deseasonalized is given by our actual figure, which is 15653 divided by 1.33, which gave me 11769.17. So those were her deseasonalized sales. We're going to round it to the nearest whole number in this situation, which gave us $11,769. So we've smoothed that figure out just a little bit. The question is, when they give me deseasonalized data, how do I turn it back into the raw data or the seasonal data? Well, we have a formula for that. And again, as long as you put it in your summary books, or learn it, then life is good. Actual figure in this situation is equal to our deseasonalized figure multiplied by the seasonal index. So realistically speaking, those of you who are doing methods and know all about sort of transposing formulas, all we've done is transpose the formula. So let's see, we have an example. The seasonal index for spring was given by 0.85, and last spring a beach kiosk's deseasonalized, notice the word there, deseasonalized cold drink sale was, so the deseasonalized des was equal to 10870. What were the actual sales? Well, I've seen the word actual, and we know then we can use the formula that actual sales is equal to the deseasonalized multiplied by my seasonal index, which was 10870 multiplied by 0.85, and it just so happens I've done this on my calculator, highlighting the value there. Gives me 9239.5. All right, and obviously we would then round that to an appropriate accuracy given by the question. Sorry, I had to think about that one for a moment. Now, that's the reason why we're doing it and the formulas and what have you. But now here gets to the crunch bit, because we're now going to deseasonalize a time series. So we're now going to be using the theory, and we've got some sort of data I'm now going to use to be able to smooth it out. None of the data I could at this moment in time could be smoothed because it wasn't necessarily set up that way. We were talking about seasonal indices as being some sort of comparison, but now we're going to use the seasonal indices to smooth more data. Here's this. So we generally deseasonalize data over a number of seasons or years, and years. All right, so the following example has once again been taken with permission from the Cambridge Further Maths textbook. So thank you very much to Cambridge for allowing me to do that. Okay, so the quarterly sales figures for Mikey's shop over a 3-year period are given, and use the seasonal indices. Now, at the end of this example, or a bit later on in this video, I'll show you where these seasonal indices have come from, but let's use them to deseasonalize first and chunk this video. All right, so use the seasonal indices, that's these values here, to deseasonalize these sale figures. My answer is correct to the nearest whole number. Easy peasy lemon squeezy, he says. So the first thing we're going to do is we're going to look at summer, which says 920. And we need to make sure that we use its seasonal index to deseasonalize. And finally, how do we do this? With a formula, of course, and this again should be written in your formula book. So to deseasonalize a figure, take the actual figure and divide by the seasonal index. So we are going to do in one of the boxes 920 divided by 1.03. Okay, so let's bring up my CAS. And there we go, we're going to main. Let's clear down what we had before so that it's not so confusing. 920 divided by 1.03. My decimal point didn't come out there on there. And that gave me 893. Now the question said to the nearest whole number, so 893 it is. So there we go, 893 would go in that box there. What do we do next? Well, surprisingly, we go back now and, well, what's the best thing to do? We could work across my table and do autumn, winter, and spring. But my advice is, well, you may get confused. You may end up putting the wrong seasonal index in. Cool. Have to get my teeth sorted. So what I'm going to suggest doing is actually doing all the summer values first. So the next one would be 1035. So 1035 divided by 1.03, and that's put that decimal point back in there. So again, 1035 divided by 1.03 and hit enter gives me to the nearest whole number 1005. So 1005, and let's just do the last one, 1229. So 99 divided by 1.03, 1299 divided by 1.03 gives me the staggering value of 1261. So they are all my summer values done. It's time to move on to my autumn values. So let's just clear some of this down so that it's easier to see. My autumn starts with 1085, but now my seasonal index is 1.15. So we now do 1085 divided by 1.15. 1085 divided by 1.15. Ooh, 1.15. Gives us 943. And ladies and gentlemen, you would just continue the table doing that. And that will give me my deseasonalized figures. Now, why are we doing the deseasonalizing stuff? Because with the deseasonalized data, we can look for trends and come up with some sort of least squares regression line and blah, 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 all that stuff from previous videos. So scrolling up, we can see that my data there was in fact correct, or the ones that I have done. So I'm going to just minimize my calculator for a moment, so give myself some screen real estate. And now, having got my deseasonalized data, we can plot it. And how do we plot it? Well, again, we have to be careful with how we construct our data in our statistics. Yeah, as you can see here, we have years and we have seasons. Now, our calculator is not going to let me do that. You know, if you remember, for all the other data where we had January to December, we labeled it 1, 2, 3, 4, and all the way up to 12. How do we do this? Well, pretty much the same way. What I'm now going to do is have year 1, and then we're going to have summer, autumn, winter, and spring. Then we have year 2, which also has summer, autumn, winter, and spring, and year 3, which has summer, autumn, winter, and spring. How's it going to help me? Well, now what I'm going to do is call that 1, 2, 3, 4, 5, 6, and we'll go down all the way to 12. So we'll now start thinking of all of these 1, 2, 3, 4, 5 as season numbers, and we are going to need to use this later on with our regression line. So as you can see from my calculator, what have I done? Yes, I have got years 1 through to 12, and I have my seasonal data in. Now, why have I put my seasonal data in there? Because I wanted to compare and show you, because again with the SAC you may be asked compare, and then what you'll notice is I've got my deseasonalized data, the 893 all the way down to 1267. The rest of it we've done over and over again in previous videos. So what we do is we hit this little button here, we bring up and make sure we're on graph 1 and show it by clicking it on. We want an XY line. This is a time series graph, so we're going to be able to connect between the dots. And we've got main and season. Now that's my first graph because I want to try and compare this. Okay, now this is new. We haven't done this in a previous video, or you may not have done it with me, but you may have done it yourself. What I can now do is click on this second tab, make sure it's switched on. Again, do an XY line but this time I'm going to do year versus my deseasonalized data, okay? And that will give me my original graph and my deseasonalized graph. Now, obviously I could have done this on my calculator, but I think it's quicker just to show you the screenshot. And lo and behold, there we go. What do we notice? Well, we notice our blue line here is our original data, and yes, it is seasonal. Do you notice it has that repeating pattern that actually falls in a time period of 1 year or less? We like that seasonal data, 1 year or time periods less than a year that are repeating. What is this red line? Well, hopefully you will agree that that now is a lot smoother. Hence, deseasonalizing this will allow us to have a smoother line, and then hopefully our line of best fit or our regression analysis or least squares regression line will fit that beautifully. Now, as I said, we sort of jumped a step really, because I basically said, well, we're just going to use these seasonal indices here without explaining where they came from. Well, now, ladies and gentlemen, we're going to explain where they came from. Now, it's a fairly intensive process, so I'm going to go through it fairly quickly, but obviously you can have the opportunity of watching this over again. So the first figure for summer is 1.03. So we're going to somehow get seasonal indices for all of these summer values, for all of these winter values, for all of these, autumn values, all of those winter values, and all of those spring values. And basically, the whole process is average and average and average again. Ish. So what we're going to do first is find the seasonal indices for each of those values for year 1. We're going to do exactly the same thing for year 2, and surprisingly exactly the same thing for year 3. That will give me a table of seasonal indices. Then what I'm going to do is effectively average the summer seasonal indices, average the autumn, the winter, and the spring, which will give me those values here. So let's do this step by step. Year 1, so I've taken the raw data values and put them in the table there: 920, 1085, 1241, and 446. How do we work out the seasonal indices for each of those data items? Well, first things we've got to do is work out the average for that whole year. How do we do that? Well, as I show on my computer or calculator screen, to work out the average for the whole year, add the values together, which gave me 3692, and divide it by 4. Why? Because there were 4 data items. That gave me an average of 923. How do we work out the seasonal index? We take the actual value. So the seasonal index, if you remember, is the actual value divided by the yearly average. So for this first value here, I'm going to do 920 divided by 923. That will give me the seasonal index for that value. For autumn, I'll do 1085 divided by 923. For winter, 1241 divided by 923, and obviously the same for spring, but with its values. And ladies and gentlemen, when I do this, up comes my table of seasonal indices. And just so you can check your own calculator working, here were my original values, each of which I've divided by 923. And there we go, we have my seasonal indices. Now, my advice to you here is give it to as many decimal places as you possibly can. 3 seems to be sensible, so that later on, when I average these down, I have 2 decimal places for my answers. So for all the way through, try and keep your answers as long as you possibly can. So I now have my seasonal indices for year 1. I finished. Nope, because as I said to you, we're now going to have to do year 2. So repeating the process for year 2, if you remember, you have to do it step by step. So to work out the seasonal index, I firstly have to add all of those values together and divide by 4 to work out my average, which is what I've done here, 1035 plus 1180. All of those values added together gave me 4112. Divide by 4 gave me 1028. Now that there is the value that I'm going to divide each of these numbers by. So 1035 divided by 1028. And there we go, 1035 divided by 1028. And 1180 divided by, and again, what do I do with each of these values here? Well, they're my seasonal indices. So 1.007, 1.148, and so we go on. And again, all of these notes are downloadable from mathsguru.com. All right, repeat for all of the years. So I've done that now. So having gone on and I've done my 3rd year, what I've done is put all of my data now in this table here. So these are my seasonal indices for each season for each year. All right, so we can now calculate our 3-year average seasonal indices by taking the averages of each season. So how do we do that? Well, again, what I'm going to do is just pull this up just a little bit so you can see. I delete this. I'm going to take each of my summer values, 1.0997, 1.007, 1.098. There we go. Add them together and divide by how many are. That's how to take an average, take the number of data items, divide by how many there are. 1.034, round it to 2 decimal places, and the world goes crazy because 1.03 is exactly what I was looking for. Same for autumn, add these values together, 1.176, 1.148, and 1.119. Divide by how many numbers there are gives me 1.147, which when we round to 2 decimal places gives me 1.15, and ladies and gentlemen, we have just done something pretty lengthy, pretty confusing to a lot of people, but hopefully now you've got this sussed, you've got this video to come back with. Now, the last thing that you need to know is this section here, and it's probably the most confusing of this whole video, because it uses a little bit of algebra, a little bit of sort of lateral thinking, but I can guarantee you there are questions on this every single year of some part of your exam paper. All right, so just make sure that this is the stuff you've got in your summary book and you understand. There is another video coming up where I'm just going to answer questions from exams on seasonal indices, just so you know how to do each of the questions. It will make this video too long if I put them in here. Okay, so notes about correcting for seasonality. We have this formula. We've had this formula that says the deseasonalized figure is equal to my actual figure divided by my seasonal index. Now, the great thing about maths is I can split this up by using a bit of fraction stuff. Hold on a moment, did I feel you shudder? I think you shuddered. I know I said the word fraction, you shuddered again. But unfortunately, it's a necessary evil in mathematics. So how am I going to do this? Well, my deseasonalized figure, so I'm going to write that as des is equal to my actual figure, and I can split that up into 1 on, or multiplied by 1 on my seasonal index. Now, if you're not sure how that happens, well, think about fractions in the sense of, I know that any whole number is divided by 1, and when I multiply the fractions, which is the easiest thing in the world, I multiply the top two things together. Well, actual times 1 would give me actual, and 1 times seasonal index would give me seasonal index. Now, why does this have anything to do with the price of fish? Nothing to do with the price of fish. So here is my new formula. So what we sometimes are asked in questions is for the percentage change in my actual value compared to my seasonal index, all right? So, deseasonalized value. So let's move up a bit. It says if a seasonal index was 1.3, then substituting in this. So all I'm going to do now is I'm going to take my seasonal index, that part of the formula, and multiply or put in 1.3. So des becomes equal to my actual multiplied 1 on 1.3. Now we can work this out on a calculator, all right? We can work this out on a calculator. So when I bring up my calculator and do 1 divided by 1.3, I get 0.769. Right, so this is this value here, 0.769. And we go right the way back to the very beginning of this video, because that's a percentage multiplier, or it sort of can be. Yes, well, we can think of it as that way. Now, what does that mean? My actual figure multiplied by 77%, all right? So I'm going to end up with 77% of my actual figure as my deseasonalized figure. That's 70%, 77%. So what does that mean? Because the question won't ask you what percentage, or it's highly unlikely to ask you what percentage, it'll ask you what percentage increase or decrease it is. And again, going back to the beginning of this video, we always reference this to 100%. So I start with 100%, I'm going down to 77%, and in this situation, we would say there was a decrease by 23%. So to deseasonalize that figure, I would need to reduce it by roughly 23%. Same would be true of, as another example, what if I had a seasonal index of 0.7, for example? Then I would know that my deseasonalized would be my actual value multiplied by 1 on 0.7. Fire up my calculator, 1 divided by 0.7 gives me 1.429. So that becomes equal to the actual times 1.429. Now I just got to realize that this value here is a percentage, or it can be thought of as a percentage. So it says take my actual value and multiply it by 143%, all right? Or make my actual figure 143% bigger than it started. How would we think of that? Is that a percentage increase or a decrease? It is in fact a percentage increase. So in this situation, if we realize that 100% to 143% means that I've gone up by 43%, or a 43% increase, and then we will be able to answer all of these fascinatingly challenging questions. All right, ladies and gentlemen, that's the end of this lesson. Thank you so much for watching this on Seasonal Indices. As I say, another video will follow with exam questions linked or relating to Seasonal Indices. That will be uploaded in a few days' time. Hopefully you found this interesting. It's long, I know that, but it is massive. If you have enjoyed the video, leave a comment below. If you can subscribe, that would be awesome. There is a doohickey over there in the corner coming up now, or a circle coming up now. And if you can spread the word to your friends, that would also be good as well. Thank you so much for taking the time to join me today. I look forward to seeing you in another video. All right, take care. Bye-bye.